1,000 miles above the Earth. We seem to be fixed above a motionless sphere. The stars and sun drift past in a daily cycle.
Estimating 05 at 0444.
Roger, market. Confirming LSV 977, ready for time.
Roger.
Survey, this is Grapevine. We're sending in a package. You will lock on at 0515. How's the weather down there?
Roger, this is Survey. Rendezvous 532. A little rough on the Indian Ocean, Grapevine.
Star Watch, this is Grapevine.
This is Starwatch. Go ahead.
We have a package for you on the web. Sending out at 0529. You will acquire on your own at 1151.
Grapevine, this is Archimedes Station. We have a man on the loop for pickup and deliver. Please bring him in.
Roger, Archimedes. His package is standing by.
Grapevine, this is Alamar Ground Control. We have a K-300 payload for you. Now counting down.
Roger, market. We have a Spider proceeding to rendezvous on 977, over.
Everything that's needed out in space gets there the hard way. Nothing here is easy or simple.
Attention in the center. This is Launch Control counting for Logistics Support Vehicle 977 on schedule. All command functions clear. Stand by. At -4 minutes and holding for priority 1.
The main expense in supply operations is getting the payload into space. Special jobs, such as personnel transfer, are handled by Aerospace planes, capable of maneuvering in and out of the atmosphere. The larger a payload, the less it costs per pound to orbit. Big recoverable boosters are the workhorses for 100 and 200-ton cargo shipments. Food, medicine, tools, replacement parts, materials, and fuel. Dehydrated, vacuum packed, and sterilized. Weighed and balanced. Nothing wasted. You can turn one of these containers into a solar battery or a shielding patch. Take out the cathode tube and eat the wrapper. 1 million pounds a month pushed into orbit.
Everything is part of a vast equation. The performance of every component in space is continually monitored with great precision by our facilities here on Earth. The data system knows how and where each component fits, knows how much current a transistor will draw, and predicts when it will fail. Computers tell us just what and how much food a certain man will need next week. They design the ideal payload mix, program package construction, establish delivery times, give us a schedule for maximum economy. Our job is to meet the schedule. If we don't, a vital machine might stop working. Somebody could die.
Grapevine, this is Market. LSV 977 has completed mid-course correction. Melbourne reports we are in the pipe and all data working.
Roger. I should get an IR track in about 5 minutes. There was a time in the Air Force when a pilot didn't have to be an expert in astrophysics or math. Now you have to get a PhD in everything, even yoga, to fight the strain and claustrophobia. Asleep or awake, you're always falling. Everywhere you look is down. You can watch your hometown from here, see whether it's snowing or if spring has come. It's a lonely job, but other men out here are lonelier than you. On the milk run to the moon, or riding a research probe to Venus. Sometimes you catch them talking to themselves over the monitor band.
Just making sure she's putting out here. Thank you much. We cleared your...
There's a bond more than a radio between us, though. We all grew up together. In test chambers and indoctrination rooms. Training for space since we were kids.
Confirming acquisition check. You are locked on and closing.
They parked the shipments in our orbit 50 miles behind the Webb. That's a small safety margin at 7,000 miles an hour. Final homing and first contact is a tricky maneuver. That's where the pilot comes in. When you want to move a 150-ton mass in space, the force must be perfectly placed to control inertia and moment. Nothing stays at the transfer station for long. It's either coming or going. We break the shipments down, recombine the packages for their final destination. They put up new activities and stations all the time, but we keep the schedule going.
The cost of spaceflight is enormous. No one can afford the luxury of waste or duplicated efforts. Yet sometimes it's more economical to replace an item than repair it. Communication relay satellites are such expendable items. But most stations are far too costly to abandon. Damage and wear in manned operations require continuous repair. As needs change, modification and revision become necessary. Servicing techniques must be compatible in all systems. There are strategic outposts whose missions are so vital that constant maintenance is more than an economic necessity.
Materials exposed indefinitely to the hard vacuum deteriorate from thermal stress, evaporation, and ionization. They are affected by radiation and meteoroids. A possible collision with orbiting space junk is an unnecessary hazard, but disposal of waste and obsolete hardware presents a problem. Sometimes we can fire it into the Earth's atmosphere to burn up. Other times it goes into the sun.
The engineers of spaceflight were up against reliability factors of close to 100%. Every part in every system had to be tested on the ground and in space. Tools were designed right along with the parts. The blueprints of the supervisors had to stay on Earth. Details sent up by remote control. We're out here because a man can take the place of a lot of switches and hardware. It was a rough job, standardizing the pieces, training the men to make them all fit together. But it saved time and money in the long run. It kept creative minds free for more important jobs. They could rely on us to put their projects up and keep them going, and to be prepared for things that go wrong.
Voice negative.
418 did not go on to automatic.
Command malfunction from internal damage. Roll gyro in slow correction mode.
Your displacement rate is additive, 21 feet per second. Approaching escape velocity.
Getting a track.
Looks like he's going in.
Station 9 has intercept capability. Stand by, 9.
Somewhere out there, a man is in trouble. A living particle falling into the sun.
Cable, this is Accent. He should be on infrared by now. This is Cable. Okay on IR. We're coming up fast. All right, his engines have stopped firing, but he's tumbling badly. Margin is 3 minutes. Retro and recover orbit in 3 minutes.
You can't hurry a docking maneuver. Too much speed and you'll crack a vacuum seal. A leak in that chamber and you'd pop like a toy balloon.
You have a return orbit to Station 10 on the spool. Roger, Accent. Station 10 looks good.
The machines of today will be gone in a few years. A breakthrough comes along, equipment changes, new systems evolve. These early years of astronautics will shape the long-range operations of the future. As he travels deeper and deeper into space, man must endure voyages lasting many years. Logistics will precede his journeys, will support his missions, will be his lifeline in space.